In this video, we're going to go over the examples that deal with using those formulas to prove identities. So our example 6 says, prove the identity. In the numerator, we have cosine 4t minus cosine 2t. In the denominator, we have sine 4t plus sine 2t. And on the right-hand side, we have a negative t. Okay, that is again, pretty straightforward example. We're going to take that left side and apply our formulas for first for the difference of cosines in the numerator and for the sum of sines in the denominator. So we're going to apply those two formulas. Straightforward. So here I just copied the left side and I'm going to apply the formula. And I want to draw your attention to the fact that cosine alpha minus cosine beta is the only formula that has a -2 coefficient in front. So don't forget. So that's going to be a -2 sine of alpha plus beta divided by 2. Multiplied by sine of alpha minus beta divided by 2. So that's my numerator. And the denominator is a 2 sine of 4t plus 2t. By the way, this is t. Divided by 2 cosine 4t minus 2t divided by 2. Well, we could see right away that this factor in the numerator matches the factor in the denominator. So these will cancel out or turn into a 1, right? And so will 2 divided by 2, that's also a 1. This negative stays. So we're going to have negative sine of 4t minus 2t is 2t divided by 2, is just going to be t over cosine 4t minus 2t is 2t divided by 2. Again, that's just t. So, and sine over cosine is tangent, right? So I have negative tangent t, which is actually our right-hand side of this identity. So we did prove it. And let's try one more, and that's going to be example 7 in this section. And we need to verify that cosecant squared theta minus 2 actually equals the cosine 2 theta divided by sine squared theta. Well, let's see what we can do. What I want to do, to me, the right side actually looks more complex than the left side. So I'm going to start with the right side this time. And the right side is cosine 2 theta divided by sine squared theta. And okay, I see the sine squared theta on the bottom, and that reminds me of the formula that we saw earlier. The formula is the cosine of 2a equals 1 minus sine square A. Okay, remember our formula for double. So we could have cosine square A minus sine square A, or if we actually replace the cosine square A with 1 minus sine square A. So here we have 1 minus sine square A minus another sine square A. So this is going to be 1 minus 2 sine square A. Okay, so I'm going to use this formula to substitute here to make that substitution. So this is 1 minus 2 sine theta, sine squared theta. Okay, and sine square theta on the bottom. Okay, now I'm going to separate into two fractions. So it's going to be 1 over sine square theta minus 2 sine square theta over sine square theta. Of course, I'm going to cancel these factors, and I'm going to write, instead of writing 1 over sine square, I'm going to write 1 over sine theta squared. And I want you to think about how these two are the same thing. Here I'm going to have 2. Now, what is 1 over sine square theta? That's cosecant, right? Cosecant theta. So we have cosecant squared theta minus 2. And that equals our left side. So our identity is proven. Now I want you to try by yourself. This is our try number 5 for this section. And you need to verify identity tangent theta cotangent theta minus cosine squared theta. And that all should equal to sine squared theta. So go ahead and try to verify that identity. Again, pause here if you have to. And I'll see you in the next video for the next section.